Here we are at the last video, part 4. We last left with understanding that we had a screen capture going on, that it was capturing the screen and it was sending out to the bad guys as JPEGs. And so now we would really like to see what that JPEG looked like. So the last part of the last technique is, how do you extract information from the frame? Of course, the information that you're extracting depends on what kind of information they're sending, but we know they're sending JPEGs here, so that's what we're going to look at, is how you pull a JPEG out. So this was our capture here. Here the cap screen. This is the details here, but that's kind of hard to work with. It doesn't give us the tools that we need, which is why we did the follow the stream and came up with this window right here. This is the hex dump. This let us see both the ASCII decode and the hex at the same time, and helped us use the ASCII to kind of see where to start looking for the signature of the beginning of a JPEG file, JFEF file, and then we saw the Fox Dog 8. We saw that began the file, and we went down to the end and we saw Fox Dog 9 down here, and so we know that is that is the JPEG. So we're going to switch. So now we need to figure out a way to actually view this file. And so what we need to do is we need to trim off some of this extraneous stuff here. The stuff at the beginning of the file is part of their part of their attack, and JPEG is not going to have any idea what to do with it. It's expecting the file to begin with Fox Dog 8. So we're going to go to the save or show and save, because we want to save. And we're going to go here to raw. And so now this is just pure hex. And that's what we want. We don't want any kind of ASCII interpretations on here. And remember, the blue is the inbound, the red is the outbound, and so we don't want that on there either to confuse things. So if we go down here, we have two choices as far as the direction of the conversation. We had the entire conversation going there. We can either go from 111 to 114, but we know that 111 is the attacker, and there's only 13 bytes there, so that is the very top, the blue part. This has got 85K. This is the conversation that the 114 to 111 is the conversation that actually has the ASCII the data that we want in it. So you can see now we have just the pure response, and we're going to save as, put it on my desktop, and we're going to call this screen cap, and we will save it. Now we go to the desktop. So eliminate this. So we have screen cap here. This is the file that we saved. If I open it up, well, we know what it looks like. It's a bunch of hex data. So we need to go in there though and modify this file and remove the bits that we don't need. So there is a free program called HXD. It's a hex editor. We just take this, drag it on top of HXD. It'll open up, and we see a familiar looking thing. This looks a lot like the hex dump on WireShark. The thing is, here we can go in and edit. And so here we see Fox Dog 8, right? That was same things at the beginning of the Windows decode or of the JPEG file, and here we see the JFIF here. So we know that everything above this is stuff we don't want, and so we can just highlight that and delete it. And it says, hey, you're gonna, the file size changes, right? You're deleting stuff. We say, sure, yep, nope, that's fine. And then we can do file, save as, and We'll do screen cap 1 just so we can keep the two files differentiated, just for the fun of it. And if we go to, here it is. So here's our screen cap. Like if I try to open that, it doesn't know what to do, right? So, because it's hex. Go back to my desktop. Go back to my desktop. And so we're going to look at the screen cap 1. So the thing is, Windows doesn't really know what to do with this because it doesn't have a file extension. So all we really need to do is go in and rename, do screencap1.jpg. Look at that. Not only does it recognize it as a different kind of a file, but we get a thumbnail of it. We'll double click on that, and of course Windows knows how to open that up now. And this looks remarkably like a screen capture. So, and as we saw from the capture file, there are a series of these. So they are just periodically going and grabbing the screen, grabbing the screen, grabbing the screen, and sending it to the bad guy. And so we could go down and decode each of these and get an idea of what kind of data had been exfiltrated during the attack. This isn't so interesting right here, but it definitely could be. So anyway, so we have figured out why the attack was, why we were even called in, what initiated the analysis, how we started looking at the data, how we started reducing the data into manageable chunks, understanding what was going on, looking at various parts of WireShark to understand the players that were involved, the conversations that were happening, and how to use the various screens to then extract clues so that we can figure out what's going on. So anyway, that takes us almost to the end. And I say almost. I don't need this anymore. Bring up WireShark here. We're going to take that out, and I say almost because this is the entire capture. Right, all 778 frames. So we start here, and if we scroll down I mean, it looks like a command goes out. I mean, this is just basically command and control going out and recovering the screens, doing screen captures, ordering the screen captures. So where in this trace did it start? And the problem is that we really don't know. We don't know. The host was infected. We don't have that information. The host was infected at some earlier time, and then it sat there for who knows how long until command and control started interrogating it and initiating the screen capture. So we can't tell what happened, how the infection happened, but we can see what the results of the infection are. So anyway, that ends this little video series. So I hope this was helpful to you to understand how WireShark fits into the big scheme of things as far as network cybersecurity, network analysis, and network forensics. So anyway, hope you enjoyed it.